Can I bring my vocab by you sometime today, Mr. Mims, after this hour?
Did you take your wallet?
Yes.
I figured it was our loss when I was freshman.
Say again.
No, it's not.
Yes, whenever I give it back to you, you're gonna wanna rip it out and staple it and put it in your binder. Because these notes are gonna be page 26 of your binder. The vocab. The vocab is page 26. And then these notes are gonna be page 27.
Did you get it?
Oh, I didn't pass it back.
Oh, I was like.
Alright, so we're starting chapter 6 today, 6.1 angles of triangles. And this first part we're going to kind of go through kind of quickly because you've already been doing this all the way back to elementary school, middle school. Students will be able to classify angles, or I should say classify triangles by sides and angles. And students will be able to find the measures of angles of triangles using the triangle sum theorem and exterior angle theorem. Okay. Alright, so first off, what exactly is a triangle? A triangle is a polygon with 3 sides. It has 3 sides and it has 3 angles. Okay, there are different types of triangles, which I says we're going to kind of work quickly through because you've done this before. The first one is a scalene triangle. So if you see over there where it says teacher notes and it says classifying triangles by its sides, the first one is a scalene triangle. If you would put over there, a scalene triangle has no congruent sides. A scalene triangle has no congruent sides. So for scalene triangle, you're going to want to write no congruent sides. That means none of the sides are the same length. All 3 sides are a different length. All right, so look over there at those 3 triangles on the right. Which of those 3 triangles would be considered scalene? Which of those have no congruent sides? Yeah, the first one. So label that one as scalene. That first triangle would be scalene. How could you tell without measuring them that the others had congruent sides? Yeah, the lines on there tell you that they're congruent. Okay. Another type of triangle is an isosceles triangle. So for isosceles triangle, you need to write that it has at least 2 congruent sides. At least 2. At least 2 means 2 or more. So if it has 2 or 3 congruent sides, it is an isosceles. Okay. So if you look over on the right, those 3 triangles at the top, which of those would you say is isosceles? The second one, it has 2 congruent sides.
Third one too, right?
Yes, mine's the third one, isosceles.
That's 2.
Yeah, it has at least 2. It has 3. So as long as it has at least 2, it's going to be considered isosceles. So the second one and the third one are considered isosceles. And then the other kind that you have, sorry, that one's wrong. Equilateral triangle has 3 congruent sides. An equilateral triangle has 3 congruent sides. So over there on the right, which of those would be considered equilateral?
The last one.
The last one. So the last one's considered isosceles and equilateral. Now, if you're on an assignment and it asks you, it's probably going to want you to put equilateral rather than isosceles. But technically, it's isosceles and equilateral. If you do that on an assignment, if you put isosceles and equilateral, I would count it correct. If you left off the equilateral part, you would get partial credit because it's partially correct. But it would be considered isosceles and equilateral. All right, and equilateral, lateral means sides, equal sides means congruent. All right, the next one, you can also classify them by their angles based on the size of their angles. First, you have an acute triangle. An acute triangle has 3 acute angles. An acute triangle has 3 acute angles. Okay, so over there for acute, you want to put 3 acute angles. What does acute mean? Yeah, less than 90 degrees. So all 3 angles are less than 90. Okay, so looking over there on the right, out of those 4 triangles at the bottom, which of those triangles looks like they have all 3 less than 90?
The first one and the second one,
Yeah, the 2 top ones. Yeah, both of those would be considered acute. The first one and the second one, the 2 at top. So label both of those acute. None of their angles are, all of their angles are less than 90. Alright, the other kind is a right triangle. A right triangle will have 1 right angle. Will have 1 right angle. And what exactly is a right angle? 90 degrees. Perfect. Now you can either use a protractor and measure the angles to see if they're 90, but usually on assignments, if there's a right angle, it's going to have the symbol for right angle. If it doesn't have the symbol, then it's probably not a right angle. Sometimes it looks really close to 90. It can be a little bit below, a little bit above. But like I said, usually they'll have it marked. And you have, oh, sorry, which of those triangles was a right triangle?
third one.
Yeah, the third one, the one on the bottom left, that would be a right triangle. The one on the bottom left is a right triangle. Okay. And then you have obtuse. An obtuse triangle has 1 obtuse angle. 1 obtuse angle. What does obtuse mean?
More than 90 degrees.
More than 90. So you have 1 angle that's more than 90 degrees. And which of those triangles over there is obtuse?
The fourth one.
The 4th one, the bottom right. So label that bottom right one obtuse. One of the angles is going to be bigger than 90 degrees. And the book wanted us to use our protractor so that way you have to measure the angles to make sure. But the majority of these, you can look at them and see if whether or not they're less than 90. If they're 90, it has the symbol on it, and if it's, you can see if it's bigger than 90. So I just, saving work for us. All right, example. Oh, sorry, there's one more. Equiangular triangle. An equiangular triangle has 3 congruent sides. So equilateral had 3 congruent sides. Equiangular has 3 congruent angles. 3 congruent angles. So equiangular has 3 congruent angles. So equilateral, 3 congruent sides. Equiangular, 3 congruent angles. All 3 angles are the same measure. Okay. Which of those triangles were equiangular?
2.
Yeah, the second one, the one on the top right. And how could you tell that all 3 angles were the same?
Has the markings.
Yep, they all 3 are marked congruent. So the one at the top is acute and is equiangular. The one at the top on the right. Now let's do an example. It says classify the triangular shape of the support beams in the diagram by its sides and by measuring its angle. Alright, so on your paper it might be kind of hard to see. But if you look at the board, the red triangle is the support beams. And I can see that this side is marked congruent to this side, but this side here is not marked. So only 2 of the sides are marked congruent. So since 2 of the sides are marked congruent, I know that's isosceles. And then to measure it by its angles, I'll look to see if there's any right angles, and there's not. There's not an obtuse angle. All 3 of the angles are acute, so it's an isosceles acute triangle. Or you could say an acute isosceles, either way. So it's isosceles and it's acute. And none of them are marked congruent, so bless you. So I wouldn't say that they were, it was equiangular because they're not marked. Okay. All right, let's try one together. I've got some right there, that way they're closer to you. This one here, it says classify the triangle by its sides and by measuring its angles. So we're just gonna look at its sides and see if any are marked congruent. Alright, so how many of the sides are marked congruent, Abby? Two of them. So since there's two marked congruent, Lakin, what kind is that? Isosceles. Every time I say that, I think of my typing class. We were playing Mad Gab, and the phrase was "I saw some leaves," which was supposed to be "I saw some leaves." All right, and then you measure its angles, which instead of measuring it, we're just going to look at it. Grace, what do you notice about the angles? Yeah, perfect. It has a right angle, therefore it would be considered a right triangle. So it's isosceles because it has two sides congruent, and it's right because it has a right angle marked. All right, moving right along. What about this one? It says by its sides. So first you want to see if any of the sides are marked congruent. Number 5, tell us, how many sides do you see marked congruent? Okay, perfect. So there's 3 sides, so you would call it equilateral. And Nick, what would you say about its angles? Equal angle, like if all the angles are marked congruent?
Yeah.
Okay, we're not supposed to know this yet, but if 2 sides are congruent, then their base angles are congruent, which would mean these 2 are congruent to each other because these 2 sides are congruent. And since these 2 sides are congruent, that means this angle and this angle are congruent. So yes, it is equiangular, technically, but they're not marked equiangular. So what else could I have said if I did not know that piece of information right there?
Acute.
Yeah, I could have said equilateral and acute. But if a triangle is equilateral, it's going to be equiangular. And that's because of the base angles theorem, or the corollary to the base angles theorem.
We take points off for that.
No, oh, that's right. We just haven't discussed that yet. And you could, for all I know, you could have measured all of these and found out that they were all 60 degrees. Okay. Could there have been another? So we could have said equilateral and acute, equilateral and equiangular. Is there a different name I could have given it?
Isosceles.
Yeah, you could have also called it isosceles. Because it has at least 2 congruent sides, so it is considered isosceles also. So that one has multiple names. Alright. This right here, if you have colored pens or pencils or markers or highlighters, I would suggest using them. If you don't, I have some markers and colored pencils if you want to go ahead and I would get 2 different colors. I would use 2 different colors. Because we're going to label the interior angles of that triangle, and then we're going to label the exterior angles. Okay, so I would use 2 different colors. Any 2 colors, you can use pens, markers, highlighters, colored pencils, whatever you would like to use, you can use them. Alright, so over on definitions of interior angles, the interior angles are the original angles of a triangle. Okay, so over there where it says interior angles, you need to type that in, or you need to write that it's the original angles of a triangle. So if you have a triangle, the inside 3 angles are the interior angles. Okay. And then over there on that top picture on the right, if you would color in the 3 interior angles of that triangle, it looks a little bit different than mine, but that's because you're also going to label the exterior angles. But But let's say I have triangle ABC, don't pay attention to the parts that are going past the triangle, just look at the triangle. And if you would color in with one color the three interior angles, angle A, B, and C. So color those one color. Those are your exterior or interior angles. All right, and then the exterior angles are the angles that form linear pairs with the interior angles. The angles that form linear pairs with the interior angles. So write that as the definition first, and I'll give you a second before I show them to you. So exterior are angles that form linear pairs with interior angles. Alright, so I have my interior angles colored orange. Okay? An exterior angle would be, what if I were to take a triangle, and what if let's say I have this point C here, this angle C, and I were to extend this line, this bottom line out that way. The exterior angle is the angle that's made between the outside of the triangle and that line that I extended. That would be an exterior angle. So for instance, here, if I extended this line up that way, this would be the exterior angle. And if I were to extend this side, this would be my exterior angle. So depending on which side you extend, it makes up your exterior angle. At each point of a triangle, there's going to be two exterior angles, because you could either extend this side like I did there, or you could extend this side here. That's why that first picture of mine, you can see it better. Give me a second to finish coloring first. So my orange is the interior and the blue is the exterior. Okay, so if you look at my original one, and I'll go right back to the other one, depending on which side you're extending. So for instance, if I'm extending this side, this right here would be considered my exterior angle. But if I'm extending this side here, then this one would be my exterior angle. So there's two different exterior angles. And it says these two form a linear pair. So let's say this angle here was 60 degrees. How could I find the angle of this exterior angle here? Let's say
180 minus 60.
yeah, 180 minus 60. So this angle, exterior angle, would be 120. So that's how you can find the measure of an exterior angle, or this one. If you know the exterior and you need to know the interior, you just subtract it from 180 because they form a linear pair. Alright, so there was my picture of my interior and exterior label colored in. Alright, so now that we know what interior and exterior are, now let's talk about some theorems. The triangle sum theorem. So first, over there on the left, you're going to need to write what the triangle sum theorem says in words, and I will move that picture out of your way in just a second. Alright, so the triangle sum theorem says the sum, which means to add, The sum of the measures of the interior angles of a triangle is 180 degrees. Okay, so write that over on triangle sum theorem. And then, once you write that down, I have you a picture over there under triangle sum theorem of triangle ABC. And what that means in geometry language, how you would write the triangle sum theorem, you would put the measure of angle A plus the measure of angle B plus the measure of angle C is going to be 180 degrees. So A plus B plus C will equal 180. So underneath the picture, write that formula. So this is that put in words. This is that put in math language. Okay, the next theorem that we're going to use is the, and if you want to call this TST, that's fine. You can always abbreviate triangle sum theorem TST. And here's my favorite, exterior angle theorem. I always abbreviate it EAT. It says, the measure of an exterior angle of a triangle is equal to the sum of the measures of the two non-adjacent interior angles. So let you get that written down first before I explain it. And then over there underneath the picture that I have on the right side under exterior angle theorem, you need to write the formula. The measure of angle 1 equals the measure of angle A plus the measure of angle B. All right, so what this means is if you have an exterior angle over here, okay, let me give this angle measure, angle C, this angle right here is, let me say that it's 40 degrees. Okay, if this angle here is 40 degrees, and these two form a linear pair with the exterior angle, what's angle 1 going to have to be? If angle C is 4, or if this angle ACB is 40, what's angle 1 going to have to be? Yeah, it's going to have to be 140 because they have to add up to 180. Well, if C is 40 and A, B, and C have to add up to 180 because of the inside our triangle sum theorem, so all three of these have to add up to 180. Well, if C is 40, what's these two going to have to add up to be? If they all three have to add up to 180. And this one's 40. What are these two going to have to add up to be in order for it to equal 180? 140. They're also going to have to be 140 together when you add them together. So that's why if you know this exterior angle or you know these two, then they're going to be the same. These two are going to add up to be whatever this one is, the exterior angle. All right, so let's do an actual example. Let me show you an example. I believe on here I've got two teacher models. It says find the measure of angle 1, then classify the triangle by its angles. So I don't have to do it by its sides, but I do have to do it by its angle. All right, so I noticed that this one's 78 and this one's 31, and I need to find this angle here. Okay, well, these are all interior angles, so I know from the triangle sum theorem that they have to add up to equal 180. Okay, so first I would see what these two add up to be, 78 plus 31. That's 9, that's 10. So these two add up to 109. So to figure out angle 1, I would just do 180 minus 109. And that's 71 degrees. So the measure of angle 1 is 71 degrees. Okay, then it says classify it by its angles. Alright, so I'm going to look to see, are any of them 90, are any of them obtuse? They're all three acute, so that would be an acute triangle because they're all three less than 90. And they're not the same, so I can't say they're equiangular. So that would be acute. It also looks to be scalene, but it didn't tell me to do that. It just said by its angles. Okay. Alright, so angle 1, 71 degrees, and then it's an acute triangle. And then let me show you one using the exterior angle theorem. It says find the measure of the exterior angle. Well, 2 is the exterior angle right here. Well, the exterior angle theorem says that this angle is going to be equal to the 2 interior angles that's not next to it. So not this one that's next to it, but these 2 over here. So all I have to do is add up these 2 angles. So I would do 64 plus 75. And 6 plus 7 is 13. So the measure of angle 2 would be 139 degrees. And it didn't say anything about classifying the angle. If I did, I could do 180 minus 139, and that would give me 41. So this angle would be 41 degrees. And they're all three acute, so that would be acute. All right, let's try one together. Find the measure of the indicated angle. This one's marked 20, this one's marked 130, and this one's blank. So I need to figure out what this angle is. So first, the triangle sum theorem says if you add up all three of the interior angles, they add up to be what? Added. Yeah, they all three add up to 180. Okay, well I need to see what these two add up to. So I need to do 130 plus 20. Grace, what's 130 plus 20? 150. Okay, well if these two add up to be 150, Lakin, how can I figure out how much this one is in order for them to add up to 180?
180 minus 50.
So 180 minus 150.
Or minus 150.
Yeah. And Taylor, what's 180 minus 150?
30.
30. So that angle is 30 degrees. Now, I know it doesn't tell us this, but what would this triangle be classified as?
Acute.
Okay, why is it acute?
Well, never mind, that angle would be
Why is it obtuse?
Because one of the angles is 130.
Yeah, one of the angles is bigger than 90, so that would be obtuse. Now, these two angles here are acute, but it does have one obtuse angle, so that would be considered obtuse. All right, this next one you got to think a little bit. Find the measure of the indicated angle. And the indicated angle is this exterior angle right here. And it does not give me this angle, and it doesn't give me that angle there where I can add these two up and see what it is. And it doesn't give me this inside angle to where I could subtract it from 180. It only gives me this big angle here, and then it gives me this angle here. So, my question to you is, how could I go about figuring out the measure of this exterior angle here?
We can do 180 minus 137 and you get that angle, smaller angle beside that one.
This one here?
Mm-hmm.
Yeah, perfect. So you do 180 minus 137. And what's 180 minus 137? Y'all get 43? Okay, so this angle here is 43 degrees because these two have to add up to 180. Now I can probably figure out this exterior angle. What would be my next step? What would I need to do to figure this one out?
43 plus 102.
Yeah, you do 102 plus 43. 5, 4, y'all get 145? Perfect, so this angle here is 145 degrees. So on some of these problems, you have to use a couple different things to figure out the angle measure. All right, before you try them with your partner, what questions do you have for me? Okay. All right, so you're going to do this one here with your partner. So if you would turn, Abby, can I get you to move right here and Brett be partners? You're going to find the measure of the indicated angle. You're going to do this one with your partner, and then you have another one to do with your partner.